Welcome to Flip Lesson 32 for the 6th grade. Today we are going to look at two different ideas. The first idea is expanded notation, and then we're also going to work a little bit more with problems that deal with time. To start, we want to look at the idea of expanded notation. As we look at expanded notations, we want to think about this idea. With the number 27,321, we're really looking at a couple of different ideas. First of all, we can see that the 2 here doesn't represent the number 2, but instead represents the number 20,000. Just like the 7 represents the number 7,000. 3 represents the number 300. 2, the second 2, represents the number 20. And finally, when we get to the number 1, it does represent the number 1. And if we were to add all 5 of these numbers together, we would get 27,321. Now, the idea with expanded notation is to be able to see this idea of the relationship between the number and the zeros that would follow it, or the powers of 10 that would follow it. So when it comes to expanded notation, what we're looking at doing here is we're going to separate our number in a way where we can represent that. So we start with parentheses 2, and we knew it was 20,000, so that would be 2 times 10,000. All right. Then we're going to add our 7,000. That would be 7 times 1,000. And then we're going to add 3 times 100. And then our second 2 times 10. And finally, our last one, which is 1 times 1. And so here we see an expanded notation of the number 27,321. If I were to extend the page, and now we can look at it in a backwards way. We can say, okay, here is expanded notation. What number is being represented here? So by doing the multiplication, I know that 5 times 100, actually that says 10,000. There should be an extra 0 here. 100,000 would be 500,000. All right. And so I'm not going to put the zeros in here because I have other numbers to add in here. Next, I have a 6 in the thousands place, and I have a 9 in the tens place. And so then I'm going to fill in zeros in all my missing places. So I have 1, tens, hundreds, thousands, 10,000, 100,000s. And so I've taken my number from expanded notation and turned it into a real number. So we have this idea of expanded notation. The other idea we want to look at is the idea of time elapsed problem. Now we've done some of these already, and we have the formula where L minus E equals D. So the later minus the earlier equals a difference. And so let's go ahead and set up this problem. It says if Johnny started his homework at 5:15 p.m. and finished his homework at 8:10 p.m., how long did Johnny work on his homework? And so if we put this down, we're going to put 8:10 as our later, and we're going to subtract our earlier, and we can go ahead and start to do the math. But as we start to do the math, we run into a problem real fast because we can't subtract 5 from 0. It's impossible. And so this minus this just can't happen. So in the end, we're going to have to borrow. But when we borrow time, it's different because we're not necessarily borrowing a power of 10 or a section of 10. But instead, we need to borrow an entire hour. All right? And so if we have 10 minutes here, we're going to actually go to the hour, and we're going to take an hour. So this is going to become 7. and now we need to add an hour to our minutes. Now when we add an hour, we're not adding 100 minutes, we're only adding 60 minutes. So we're going to add 60. So 60 plus 10 is going to give us a combination. These two together is going to give us a combination of 70 minutes. And we're going to need that to be able to solve this problem. So now that we have 70 minutes, now we can start to subtract 15. Now we still have our 0 minus our 5, but now we can borrow minutes. And when we borrow minutes, right, if I take a minute from here and make this 6, now this will become 10. All right, the 0 will become 10. All right, because there are, as we're going up to 60, now we're working once again in powers of 10. So 10 minus 5 is going to give us a 5, and 6 minus 1 is going to give us a 5. And then we can go over here and subtract our 7 minus 5. All right, and in the end, we find out that it was 2 hours and 55 minutes to do that. And so we have an example of a time-lapse problem. Another example would come in this form. What is 2.5 hours after 11:41 a.m.? All right. Now technically our equation is later, we don't know, minus our earlier of 11:41, right, is going to equal 2 hours and 30 minutes. All right, 2 hours and 30 minutes. And so to reverse this, to solve this equation, in the end we're going to add these numbers together. So it's going to be adding 11:41 and 2:30. So as I work with that, that'd be 11:41 plus 2 hours and 30 minutes. And so as I start adding these together, I get a 1, I get a 7, and I get a 13. Which, as we add those things together, we realize that that's not how time works. We don't have 13 hours and 71 minutes. So now we got to start doing some converting. All right, start doing some converting. Since this is 11:41 a.m., that means the instant we get to 12, we're going to switch to p.m. All right, and so 13 is 1 more than 12, and so we went from 11 to 12 to 13, so the hour 1 plus 12 p.m. would be 1 p.m. All right, so our 13 really represents a 1 p.m. But we still have 71 minutes here, which of course is not a part of an hour. We know that 60 minutes equals 1 hour. So if we were to take 60 from our 71 and turn it into an hour, we would end up getting, we're going to add an hour onto our 1, so it's going to make that 2 o'clock. And after we subtract our 60 minutes, since we took that 60 minutes and put it into this over here, we're going to be left with 11 minutes. And so our answer is going to be 2:11 p.m. And so as we work with time-elapse problems, we're really working with, well, what happens if our numbers don't really subtract real easy? How do we deal with time, borrowing time and converting time based upon a 60-minute scale? And so that's the idea of time-elapse that we're going to add. So here are a couple sample problems for you to work on, one with expanded notation, one with time-elapse, and you can use these to help you with your lesson today. That's it for lesson 32.